geopolymer concrete. When you consider the fly ash-based geopolymer concrete, the source material is low calcium fly ash containing high silicon and aluminum. Now you may ask the question, what about high calcium fly ash? We can use it, but the high quantity of the calcium present in this fly ash will interfere with the polymerization process and lead to reduction in strength. Alkaline liquid, combination of sodium silicate and sodium hydroxide solution. Source material and alkaline liquid, both you mix, you'll get gel formation. Gel binds the coarse aggregate, fine aggregate, and unreacted source material, which finally leads to geopolymer concrete. Advantages of the strength at early ages. When it's steam cured, within a period of about 24 to 48 hours, we will get the strength equivalent to that of 28 days strength. High durability, resistance to chemical attack, resistance to fire. Then changes the industrial byproducts into, this is very important, into useful byproduct. The geopolymer technology could reduce carbon dioxide. So the utilization of waste products and the control of carbon dioxide emission, and these two are very important. Side by side, the ground contamination and air pollution, everything is taken care of, and sustainable concrete, which acts as a powerful tool against global warming. Now, when you compare this geopolymer concrete development is on one side, and the other side, the fiber reinforced concrete, a lot of research work has been carried out in the case of fiber reinforced concrete. When you have the geopolymer concrete with the fibers, that will improve the concrete to a great extent. When you add fibers to concrete, that reduce micro and macro cracking and restrict widening of crack. That's very important. And the better energy absorption capacity increases the toughness, flexure, tension, compression, increase the flexural impact and shear strength, improves durability. So try to combine this geopolymer concrete and the fibers. So when the fibers are added at random to geopolymer concrete, that improve many of the engineering properties. So the idea of the present keynote lecture is how to study, or what are the various experimental studies which have been carried out in the field of fiber reinforced geopolymer concrete. So when you look at the fly ash, class A fly ash, and this is obtained from Metal Power Plant, Tamil Nadu. This is the composition of the fly ash using the scanning electron microscope with 2500 magnification. So all spherical, that is around particles, and roughly about the values are given about 1 to 10 microns. The alkaline liquid considered in this is sodium hydroxide and sodium silicate. Sodium hydroxide in the form of pellets and sodium silicate solution, and they were mixed to obtain the alkaline solution. So the geopolymer concrete nothing but the fly ash which is activated using the alkaline solution. And two different, that is a coarse aggregate considered here and fine aggregate considered here. The values are given 2.712, 2.5, fine aggregate, fineness model of 7.1 and 2.83 and so on. So all the general properties of the materials. Superplastization is required because we are adding fibers. So in order to improve the workability, we require superplastizer, and the fibers considered in this case is crimped steel fibers. Why this crimped steel fibers? That will improve what is called the bond between the fiber and the surrounding matrix. The length of the fiber is given here. One important aspect is aspect ratio. Aspect ratio is nothing but the length of the fiber divided by the diameter of the fiber, L by D ratio. That is aspect ratio. And ultimate tensile strength of this fiber is given as 800 megapascal. So mixed design. Actually, there is no special mixed design as far as GPC is concerned. However, we can follow the international guidelines given by Professor Rangan, who has done a lot of work in this area. Professor Rangan from the University of Australia. Trial and error method based on the guidelines provided by Professor Rangan was followed for designing M40 grade GPC mixed proportion. The objective for performing the trial and error procedure was to obtain the desired compressive strength at the end of 28 days. Because straight away we cannot get to the 40 grade compressive strength, so we may have to do some trial and error. In good cohesiveness with the satisfactory workability of 75 to 125 millimeters lump. So a total of 22 trial mixes were conducted. Guidelines for getting this mixed design. the alkaline liquid to fly ash ratio by mass, water to biopolymer solids by mass, the wet mixing time and heat curing temperature and heat curing time are selected as parameters. So in this case, steam curing was done in order to improve the strength. The mass of combined aggregate 75 to 80% of the mass of geopolymer concrete. The values of alkaline liquid to fly ash 0.3 to 0.45, and the ratio of sodium silicate to sodium hydroxide. These are all the various parameters one has to consider. Geopolymer concrete has to be steam cured at 60-degree temperature for 24 hours after casting. So using both the maximum size of cold aggregate 20 mm and maximum source aggregate 12.5 mm, two mixed proportions have been done for study purposes. Mixing, the laboratory fly ash were first mixed in a 60-liter capacity drum mixer. The aggregates were prepared in saturated surface dry condition. The alkaline liquid was mixed with super processor. Steel fibers were added to the concrete while mixing. So this is the mixer which was used, dry materials, then with alkaline solution added, and finally with the fibers which is given here, fresh GPC, and there are various modes. We have to cover this with a plastic sheet in order to prevent the movement of moisture. And properties of fresh geopolymer concrete are done as per IS 11-1999, which is reaffirmed in 1999. And that you can see in this GPC, that is without fibers, and GPC1, GPC2 with, they're all fibers, the quantity of fibers which are added. And the super, so when you increase the fiber content, we require the super processor also goes up 1.4 to 1.5, and the slump also comes down when you add fibers. So in this case, when volume fraction was increased from 0.25, 0.5, 0.75 and 1, the super processor also we have to increase, and slump slightly got reduced, and VBT time increased. And this is a steam curing chamber. It was established at the Structural Engineering Laboratory of NIT Calicut, and the details are given here. And the variation could be some 0 to 100 degree. We can adjust types of curing. Hot curing and steam curing can be done. Max operating temperature 1 kilogram per centimeter square. So boiler, so that that steam will be generated. Now the specimens are kept in the steam curing chamber. And the mold is along with the mold, after 24 hours of casting, this cylindrical mold and cubical mold, everything is kept here. And we, in addition to this, we prepared the wall panels also. There are wall panels which are here. This is again this is under steam curing. Then after this, the hardened properties were obtained, and you know that regarding as far as compressive strength is concerned, this is given 7 days, 14, 28, 56, because the polymerization takes place. So we don't want to stop with the 28 days. We want to extend up to 90 days. In the case of ordinary GPC, that increases about 42.2 to 45.94. And similarly, when you add these fibers, there is a small increase in strength, not significant. Sometimes we may get a reduction in compressive strength when you add fibers, because fibers are meant for increasing the tensile strength of the composite. And with the high volume fraction, in fact, the strength has come down, mainly due to the balling effect, and the mix becomes harsh. It's very difficult to properly compact and this and that. So this indicates that as the fiber content increases slightly, it improves. At about 0.75, the improvement was 0.75 to 0.71%. The improvement was better in both mixed proportions. The hardened properties, especially as I told you, the split tensile strength and modulus of rupture, that got increased at 0.5 and 0.75. That is given here, and at 1% also we got a slight better value. Similarly, the model of rupture has gone up, and modulus velocity with these fibers, and Poisson's ratio, and unit weight. Unit weight is roughly about 2,400 kilogram per m3. And when you increase the fiber, naturally slight increase will be expected. Now, based on the compressive strength and tensile strength and the flexural strength, numerical the empirical equations have been obtained between the tensile strength and the compressive strength with a parameter called fiber factor. That is nothing but L by D aspect ratio, L by D into VF, volume fraction of fibers. That will be useful while doing some rational design. Similarly, the model of rupture versus compressive strength. Similarly, the model of elasticity with the compressive strength. The empirical, it's all regression equations. Now, the mixed proportion finally that we have obtained is about cement, the ordinary, which is M40 grade with conventional concrete also we have used for comparison purposes. And cement 350 and 896 are all conventional concrete. Comparison of GPC and CC. And when you compare this GPC and CC, the 7-day compressive strength was 42.2, in conventional concrete was 30.4. So there's an increase in GPC with reference to conventional concrete was 38% within 7 days. But what happened? At the 28th day, the values are almost the same. Slight increase only is obtained. And in fact, at the 90th day, this conventional concrete has slightly increased the compressive strength. And the flexural strength, naturally the 5 and 4.43, and it is slightly higher, and split tensile strength 2.58 and 3.05. Model velocity, Poisson's ratio, unit weight. So it is comparable with that of conventional concrete. And we are utilizing all the waste products, and we are reducing the high energy intensity material. These are all the various advantages. Now, based on this basic study, it was extended to the what is called the flexural specimen to study the behavior of steel fiber reinforced GPC under monotonic and flexural loading, and develop models for first crack load, dirt deflection. These are all part of the research study. The first crack load is very important. So the specimen, the details have been variable considered. Specimen, beam specimen was used, and the size is given here. Type of loading, monotonically increasing the loading. And the beam designation is given here. Steel fiber content is no fiber 0.0, that is F0 GPC, and 0.25, 0.5, 0.75, and 1%. For each specimen, 2 specimens have been taken, and the average value was taken into account. And this is the reinforcement details. Yeah, these are reinforcement details for the test setup. Since we are dealing with the flexural studies, here the stirrups have been given, the shear steps have been given only the shear span, and this span was, flexural span was left free so that we get a pure bending zone there. So the specimens have been cast, and the loading was applied like that. So the casting of specimen, and the load cell and eye section is kept, LVDTs are attached, and dial gauge is for measuring the deflection. LVDTs are attached here, top and bottom, in order to measure the compressive and the tensile strength. These are all required for calculating the curvature. And similarly, the load was applied, the third point loading was applied. So this is the compression cum bending testing machine. And so the capacity is roughly about 300 tons. And the test was carried out. You can see the LVDTs, which is kept here, LVDT and dial gauges, and a load cell, and the load indicator is given here, and the LVDTs are controlled by this LVDT operator. When you look at the case of cracking of all the specimen, in the case of specimens without fibers, you have less number of wider cracks. If I ask the questions to students, will you prefer a larger number of finer cracks to a fewer number of wider cracks? Naturally, as a civil engineering student or a structural engineering student, people will prefer what is called a larger number of finer cracks rather than a fewer number of wider cracks, because wider cracks are very dangerous because they would lead to all problems like corrosion and falling and everything. So in this case, when the fibers are added, a large number of finer cracks have been obtained. And this is actually something like that. That is, when you look at if this is the beam, it is simply supported. When the load is applied, naturally the first crack will appear like that. Then a fiber will intercept the crack. Then the crack cannot travel in the same mode, so it has to take a deviate, but then another fiber will intercept. Then another fiber will intercept. So due to that, the crack simply take a deviation, and during the process, it demands more and more energy, and the load carrying capacity is increased. If fibers are not there, the crack once forms here, it will simply propagate like that. And this is mode 1 propagation. Here we get the crack will form from this point, this end, and take a meandering path. And this is following a mixed mode. We say that mixed mode. So when you add these fibers, the fibers intersect all the cracks and bridge across the crack and delay the crack propagation, and due to that the load carrying capacity is going up. And this is a comparison of load deflection plots with fiber content. We get a larger load deflection plot in this curve you can see, and you know that the area under this curve, when you take this area, that is nothing but the energy absorption capacity, load under the load deflection curve, the total area, and that will lead to a high ductile property. Test results have been used. The volume, compression, and first crack. First crack load is very important. What is the first crack load after all? The load at which the first crack appears in any concrete specimen. The first crack will appear as and when modulus of rupture is exceeded. That is the policy. So once the modulus of rupture is exceeded, the first crack will appear, and then only the steel will come into picture. Till that first crack appearance, the steel has no business. It will be increasing slightly that homogeneous properties of the concrete. But when it is the first crack appears, steel will come into picture and try to stitch the crack and take the entire burden and take care of that further loading. And here you can see that with the increase of quantity of steel fibers, there is a marked increase in the first crack load. Ultimate load, of course, is only a marginal increase. And the deflection at ultimate load, that is also very important for calculation. For energy absorption ductility factor, the ductility factor, when I say the material is highly ductile, how will you say quantitatively? Quantitatively, you can obtain using this ductility factor. Without ductility factor, we cannot say that the composite is highly ductile or not. So it is delta U by delta Y. The delta U is a deflection corresponding to 0.8 times PU. See, when I draw the load deflection curve, P delta, the curve will go like that. So this is 0.8. This is 0.8 times. This is a peak load P U, and this is 0.8 times PU. And this value, whatever the delta you have, and it's given by the various researchers. Delta U by delta Y. Delta Y is the deflection corresponding to the yielding of steel. From the elastic crack section theory, assuming that the steel was not stressed beyond yield strength, the strain in steel can be obtained. So how to calculate that delta Y? That's very important. Delta U you can always observe. Delta Y, we can use it using our elastic crack section theory. This is the normal equation, that M by I is equal to F by Y is equal to E by R equation. Then we can obtain this delta Y based on this expression. My you can calculate, and depending on your load arrangement, we can find out what is Py, and the calculation can be done. And from that, the displacement ductility factor can be obtained. Energy absorption capacity, you know that energy absorption capacity is nothing but the area under the load deflection curve, and that is seem to be very higher in the case of specimen with 1% fibers, and this is a relative value to about 1.93 times higher than that ordinary GPC. So deflection at 0.8 pu and delta y is given. The displacement ductility factor is 3.06 without fibers, and with fibers 6.87. And the relative value is 2.2. This is very important for us, because when you design the structures in order to take care of a seismic resistance, not only strength, we require a very high ductility. So ductility can be improved by the addition of fibers in such material. So similarly, moment curvature plots. We can have the curvature ductility. Whatever I have shown here is a displacement ductility. Similarly, curvature ductility can be obtained using this expression. You can calculate the curvature value using epsilon c plus epsilon s by d. Epsilon c is a compressive strain, epsilon is a tensile strain, and d is the distance between these two. That is a value of the extreme compression fiber and the that's effective depth. We can say effective depth. So epsilon c, epsilon s have been obtained using the LVDTs which are attached, and d is already there, so you can calculate. And this is a moment curvature plots. Moment and something like load deflection. Here moment curvature. And you can see that the specimens with higher quantity of fibers that encompasses all the other curves and show a high energy absorption capacity, naturally that lead to high ductility. So the ductility again was calculated. Curvature ductility index as given by Professor Park and Pauli, 5u by 5y. The values have been given here, and we could get a higher ductility in the case of the specimen with about 1% fibers. Now this is all for a smaller specimen. Similarly, load factor with respect to limit state of deflection. The load factor has to be obtained, and then for that matter, the load factor is pu by ps. For strength calculation, the value is roughly about 1.5. Now, from the deflection calculation, you can always calculate the total deflection delta as per the code is permitted. Total deflection permitted is spanned by 250. That takes care the immediate deflection and long-term deflection. Long-term deflection due to creep and shrinkage. But delta is a short-term or immediate deflection. Delta L is a long-term deflection, and delta L is obtained from another equation given by Park and Pauli, 2 minus 1.2 by compression reinforcement and tensile reinforcement multiplied by short term. So delta L, delta I, they are related by this equation. Then from that we can find out the short term deflection and find out the load factor. Load factor is very important. Similarly, load factor with respect to cracking. With respect to cracking means as per the limit state design, LSD. The maximum width of crack that can be tolerated in any RCC structures under protected environment is 0.3 millimeter. Beyond 0.3 millimeter, you say that it has violated the limit state of cracking. So we have tried to obtain a load factor with respect to deflection and load factor with respect to cracking. So you see that the load factor with respect to deflection is more than 1.5, and the cracking is roughly about 1.3 and so on. That indicates that the deflection controls the design. Why we are doing all these things? In order to find out which is more what is called important parameter. When you look at the deflection, which controls the design as far as this structure is concerned. Now, with this basic studies, the attempts have been made to extend this basic study to multi-story frames. Multi-story frames means maybe a single bay multi-story, something like that. We'll have that is maybe single bay multi-story or multi-bay multi-story. Like that. So there, in order to increase the what is called the load carrying capacity and the cracking resistance, two types of fibers have been used. Now we look at the conventional fiber concrete contains only one type of fiber. The gradual and multi-scale nature of the fracture in concrete implies that a given type of fiber can provide reinforcement only at one level, one fiber within a range of limited strains. So when you add one set of fiber, that has ability with respect to some micro or macro cracks. But when you have combination of two or more fibers, so what will happen? The two fibers, how will you take? Based on high modulus and low modulus fiber, or short or long fibers. And they are called hybrids based on fiber constitutive response or hybrids based on fiber dimensions. So in this case, the two types of fibers have been tried. Now you can see when you put the short thin fibers in the concrete, what will happen? There are short thin fibers. You can see short fibers are given. That will arrest the micro cracks that develops. And as the crack grows and form the macro crack, then long fibers will come into picture. So when the short fibers and long fibers are added, final thing is that the entire crack is bridged across its surfaces. So the main objective is to study the strength and wear of single bay multi-story frame with the SFR GPC and HFR GPC. The entire building was scaled down to 1/4 model. So steel fiber was considered, and this is metallic fiber, and this is a metal fiber, the basalt fiber, basalt rock. You know that diameter is 13 micron, very small, and here the diameter is 0.45 millimeter. Aspect ratio is 1384, and here aspect ratio is 66, and the superprocessor is required. So one is a long fiber, metal fiber, which is a long fiber, and this is a very micro fiber, and this is meant for arresting micro cracks, and this is meant for arresting macro cracks. So the ordinary Portland concrete was also done, and this multi-story frame was done. Geopolymer concrete was done with the steam curing, and this is water curing, steam, and all, with steel fiber, and hybrid fiber. Hybrid fiber means steel fiber 0.51 only. And in the case of hybrid fiber, HFR GPC, 0.5% steel fiber and 0.2% basalt fiber have been tried. And this is the mold for the multi-story frame. And the reinforcement considered was this, the beam portion dimension. It is given here. The details are there, and similarly the column side BB, which is given here, section BB and section CC. This is for keeping the specimen in the test floor, because we have a very strong floor which is having a capacity of about 20 tons at various points at every 1 meter interval. And the reinforcement gauge for a single bay multi-story frame. It's a single bay multi-story frame, 1, 2, 3-story frame. And our research scholars, they are working on that in order to monitor the strains. The strain gauges were attached to the specimens, because you can use Demek gauges on the surface of specimens, but what will happen when the load is increasing, cracks will appear, and suddenly the Demek points will fall down. So in order to obtain what are called the strains in steel, we attach the strain gauges are attached here, and the curing is going on, casting and curing, and these holes are provided in order to fix the specimen in the test floor. This is all casting. The curing was done using steam. This is geopolymer concrete, not conventional concrete. Water curing was done. So a specimen covered with a plastic sheet. After the specimen was completed, it was covered with a plastic sheet, because to arrest the moisture movement. And how this is a very large scale specimen. You cannot keep it in the steam curing chamber. So we followed a method as suggested by Professor Angan in his laboratory. We covered the entire specimen with a tarpaulin sheet, and the steam was pumped into that. And this was done for a period of about 24 hours. That pumping of steam inside the tarpaulin, of course some steam will escape, but a continuous pumping was done, and due to that the strength development, polymer action, everything took place. And the test setup. So this is the frame, and it was subjected to loading, at loading here, and it was, the thing is, it was subjected to reverse cyclic loading. That means it will be it is a frame like that, let us assume. Then it will be pushed in this direction. Then it will bend like this. Then it will be pulled back. So it is called a reverse cyclic loading. So reverse cyclic loading was done, and the deflections were measured using LVDTs, and the strain gauges were measured using data logger, and the load cell for measuring this one. These are all done on a test floor. This is a test floor. Thickness is roughly about 80 centimeter. Yeah, this typical is a 3x1, 2, 3, and 3x3 story frame, and you see so all the specimens which have been tested. It's a single bay, it's a 3 bay, and there are 2 bay, and you can see the loading arrangement. You see, this is the loading frame. That is a lateral loading frame. That is, you can apply lateral loads. RCC foundation block in order to keep the specimen in position, because otherwise what will happen, the specimen is kept here, so that we can introduce fixity as well as hinge action, everything using this type of arrangement, foundation block. And this is the load cell, which is used for applying the load here, and hydraulic pressure application system. There are 4 units are there, and you can apply the pressure. And the steel frame for keeping the LVDTs. So we require a large displacement LVDTs. Small one will not be adequate. So it's LVDTs are large, which are attached to this frame. So the beam, when you apply load, the frame will deflect in this direction. And when you pull back, there's a system. You see there is a system here. Using that you can pull back. It's a universal jack. Universal jack means you can apply tension as well as compression. So it will be pulled back like this. And the data logger. There's a data logger which is kept here. These are test structures in laboratory with this facility. Now the arrangement of hydraulic jacks for load application. And you can see that the loads are applied at this nodes. And this is arrangement for forward load application through load cells. So it will be applied. The forward load means it will be applied in this direction. Arrangement for pulling back. So it will be pulled back. So that will simulate to some extent the seismic action, which is pseudo seismic action, because pseudo dynamic loading. You cannot currently we have procured what is called another system. Through that we can apply dynamic loading. This is pseudo dynamic loading. And you can see the LVDTs are attached here, and the data logger which is connected to this specimen, and that is all the strains can be measured using this data logger. At a time, you can measure about 64 places the strains and displacement. So both LVDTs and strain gauges are connected to this data logger. Yeah, now you can see the frame, how the loads are applied. So we have the system like that. The load will be applied in this direction, and the deflection takes place, and the specimen will deflect like this. And it will be pulled back by this another system which is given here. So when this pulled back, then the specimen will deflect like this. So it will represent a pseudo dynamic loading. Of course, there may be a time gap, but anyhow, that will give you an overall picture of what happens to the specimen when it is subject to the loading and unloading and reloading, so that some portion becomes tension and some portion becomes compression. And when you do the reverse cyclic loading, the tension becomes compression and the compression becomes tension, and what happens to the specimens. Yeah, our research scholar, she is doing the test, Professor Sahana, a professor from College of Engineering in Bangalore. And this is a specimen. So you can see the cracks which develop here. And as a multi-story frame with the lateral loading, the first casualty occurs at the joints, because the joints. But in this case, what happened, when we have provided these fibers and other things, that has taken the control over this, what is called a cracking, and did not allow the spalling of cover concrete or water maybe, and improve the overall picture. That means in the case of multi-story frame, when you add the steel fibers at the joints and improve the tie spacing in the columns, what happened? You will get a confined concrete. It's another area, confined concrete. There, the concrete, what is called strain carrying capacity will be large because of the confinement, and the concrete will not crush and failure will take place as the lateral load increases. So what happened? The excess moments will be redistributed to other areas like this. And that is called a redistribution of bending moment. Redistribution of bending moment is possible only when you have a high ductile joints, beam column joints. You see the SFR GPC specimen with the 0.5% volume fraction of steel fiber. And this is when you do that loading, unloading, reloading, you will get a curve. It's called a hysteretic curve. And that will give a loading, unloading. Then we are putting in the reverse direction. Then the reloading. Like that, as the time passes, you will be getting a curve like this. And that will give you a lot of information. And how the stiffness degradation takes place as the number of cycle increases. So each cycle, one cycle, when it goes here, it's one cycle. Like that. So from the hysteretic curve, we can obtain the stiffness degradation and the ductility and other things. So this is SFR GPC specimen with 1% volume fraction of steel fiber. Again, here you can see the hysteretic factors. And now you compare that ordinary Portland concrete specimen which is given here, and this is hybrid fiber reinforced concrete portal frame. That is simply a portal frame, single beam multi-story, 0.5% steel fiber and 0.2% basalt fiber. The difference is, as I mentioned earlier, that because of the provision of the steel fiber and 0.2% what is called basalt fiber, the number of cracks developed in this case were few. The earlier case was few, and here more number of cracks, and the width of crack was very, very small, or I can say finer cracks. And here it is wider cracks. So the hysteretic curve for the conventional concrete as well as for GPC. From using that, you have to get the other parameters. Why we are doing all these things in order to get other parameters? And finally, in a nutshell, everything is given here. That is the steel fiber and basalt fiber, 0.5 and 0.2%. That improves the first crack load to a significant value. That is very important. Ultimate load, we are not very much bothered because we are more bothered about what is called the ductility and the first crack load. And the fibers may not increase ultimate load to a higher value. You will get a marginal increase, displacement corresponding to ultimate load. The stiffness degradation. For example, this is the specimen with steel fiber and basalt fiber. Initial stiffness was very high when compared to one without these fibers. And slowly it is coming down. The stiffness slowly coming down. Finally, when the number of cycle increases to say 7 or 8, it is coming to some lower level where the other curves also meet. The initial stiffness will be very high, and as the time passes, as the number of cycle increases, what will happen? The degradation takes place, and that is very important with this. HFR specimen exhibited less degradation of stiffness. Then the energy absorption capacity is nothing but the energy dissipation capacity. Remember, until the load is equal to the work done in straining, deforming the structure to a limit of useful deflection. The energy dissipation capacity during area's load cycle was calculated from the sum of the area under the hysteretic curve. So we can see the one which is having this HFR HPC, which performed better. Then the displacement, what is called a ductility ratio, that the displacement corresponding to maximum load, which is obtained delta U, and delta Y is the displacement, the yield load that has been calculated, and the ductility factor, cumulative ductility factor was very high in the case of HFR GPC specimen. That indicate that the specimen is very highly ductile, and that will not collapse all of a sudden, and that improve the overall behavior of the structure. That is very important. So whenever we deal with the such structures, for example, the such frame, this joint should be made highly ductile. What I am telling is the joint failure should not take place. And the joint should be in a position or capable of transforming the excess moments to other areas. So we have to spread the fibers only in the joints over a effective depth, one effective depth. You need not put the entire fibers throughout the column, the portion. You have to put the steel fibers and our hybrid fibers only at the joints over one effective depth of the beam, whatever it may be. And in this case, roughly about some 30-40 centimeters from the joint, up and down. Similarly, in the case of beam also. So that will increase the overall ductility of the what is called the joint. That is what is required, so that the specimen will be highly ductile and that can experience large deflection or large displacement without causing what is called a major distress. Of course, we can do all the repair using other ferro cement technique. Ferro cement technique can be used to improve the overall behavior of the joint by wrapping with the ferro cement. That is another area. Rehabilitation, retrofitting. That is another area which is gaining more and more importance, and I am sure that within a very short period that will overtake the rehabilitation industry, will overtake the construction industry. That is an order of day. And many of our students will be getting jobs in the case of rehabilitation industries, so that they can work out, they can strengthen the existing structures. That is the requirement. So probably with this, let me complete my presentation. And if there are any questions or anything, I'm ready to give clarifications.
Sir, I have a question.
Yeah.
Actually, we are doing a lot of experimental research work on geopolymer concrete. But in India, we are not using it widely. Is it because of the cost factor, or the curing is a little complicated?
Yeah, good. About 2 to 3 years back, the first full-scale model of geopolymer concrete building came into existence in Australia. And of course, a lot of work is going on in our country also. And you know that when you go for a realistic scenario, such a large building, as I mentioned, for multi-story frames and all, people have to make attempt to do this. And that's very important. In future, I am sure that only sustainable composites will thrive, because other composites which are highly energy intensive material and high time to replace them. So of course, like our self-compacting concrete, in India it came little late, while in other countries and all developed and put into practice long back. So it definitely it will come to picture.
Is it because even in the cement industry, so many manufacturers are there? So if we start using, geopolymer concrete, will be a problem for them also?
Yeah, that is a very important question. Actually, about 5 years back, when I was delivering a lecture in a conference, then I told, when you have a cementless concrete, then what will happen to the cement manufacturers? There are so many manufacturers are there. Then one gentleman stood up and he replied, "Sir, in that case, we will start manufacturing alkaline solution." Alkaline solution is required for geopolymer concrete. Of course, fly ash and other waste products are available in power stations and all, but people will go for manufacturing the alkaline solution, or they will try to develop a composite with a little bit of cement, about 10 to 15% cement, and balance what is called like that. People have to work a lot of work in this area.
Sir, another question is, I've seen those results. In that, the 90-day strength, there is not much difference when it comes to GPC.
Yeah, that's correct. There is actually a study how the it's all polymerization in geopolymer concrete, how that extends as the time passes. So the difference was very nominal.
Yeah, but finally the maximum strength attained is more in OPC.
Yeah.
That's what I've
See,
seen.
OPC, the advantage is geopolymer concrete within 24 hours or 48 hours, it has developed 28 days strength of ordinary concrete, conventional concrete. But towards 28 days or 56 days, the strength almost remains same. There is not much change. Our
Yeah,
advantage is
because
quick strength, and the utilization of industrial waste products and reduce the high energy intensity material. So it's all green concrete, we can say. Everywhere, even today's Malayalam Manorama, when I opened, the entire government of Kerala, they are going for a green office, green buildings and this and that. So naturally, all these things come into picture.
yeah, because M40 concrete, I was seeing that the maximum strength attained by the GPC is 45, whereas it is 49 for the other ordinary cement concrete.
Yeah,
Because
the reason for you see the OPC is like higher, no? Conventional,
OPC was higher, sir,
yeah, conventional concrete is there at the end of 20 after 28 days.
after 28 days.
After 28 days, the ordinary concrete will be simply sometimes it will be giving a higher value than GPC.
Yes,
Yeah,
that
I
is the
told you.
result that is showing.
Yeah,
Sir,
but
regarding one more question I have, the cracks which were showing mostly on the columns and column joints in the multi-story frames, and as you said rightly, sir, the joints should be stronger, definitely. But when we are using all these, the fibers, the columns, the beams become stronger because there was no crack in the beam. So in the joint, so will it change to like strong beam, weak column?
no. Actually, any when you design a multi-story frame, the concept is strong column, weak beam.
Yes.
Strong column, weak beam. But how will you say by mere looking at the figure, we cannot say a column is strong or a column is weak. That is based on our IS code. IS code says that the flexural capacities of the columns which are framing into the joint should be more than about 1.2 times 1.2
More
times
than that.
higher than that of the
Yes.
beams which are framing into the joint. That we have to calculate and find out. And in this case, what happened? Any multi-story building subjected to lateral loading,
Yes.
not transverse loading or gravity loading. Any multi-story building which is subjected to lateral loading, the first casualty I told you will be the joints only.
Yes.
Even if you draw the bending moment diagram, you can see the maximum bending moment at the joints, maximum shear at the joints. And once you permit this maximum moment which occurs in the joint, what will happen? The destruction of joints takes place.
Yes.
But how to prevent that? Provide confinement. Confinement in the form of closely spaced ties in columns.
Yeah, that we do. But the
Yeah.
fibers, sir?
Then, in addition to that, the fibers, when fibers are added, that will stitch all the fragments together. So even after the ultimate load, the concrete fragments will not fall. That will be stitched by the fibers, the fiber concrete, and that will improve what is called the structural integrity and dimensional stability. Both are important. Only when dimensional stability is there, otherwise, concrete once the strain increases and more than if it is 0.002 under axial compression and 0.0035 under bending compression, what will happen? It will crush, and crushing type of failure takes place. Not cracking, it's called crushing. The difference between cracking and crushing is due to tensile forces. And the first crack appears when the modular of material is exceeded. Crushing will take place once the compressive strain is exceeded. 0.002 is exceeded, crushing will take place. So when the fibers which are added, that will improve the structural integrity and dimensional stability of the material, and that will permit the redistribution of bending moments. So excess bending moments of joints will go to the beam side. Beam at the middle, it will be less. It will go to the redistribution of bending moment as in the case of plastic analysis. So that is why I told you that joint should be made stronger. Stronger means highly ductile.
Yes.
So you provide adequate confinement. In addition to that, add these short, discrete fibers. That will not improve the strength. That will try to protect what is called the section by bridging across the micro and macro cracks and improve the overall integrity.
It will arrest the propagation.
Yeah, that will simply arrest. That will not allow the cracks to follow one mode of propagation. When the fiber intercepts, the crack has to take a deviation, and it's a mode 1 to mode 2, mode 3, like that it has to go.
Okay.
So
Thank you, sir.
the confined concrete, a confined SFRC, that work we have done long back and got published in American Concrete Institute, AC structures and materials. That is well appreciated because probably our paper could be one of the pioneer work in that area. It is confined steel fiber reinforced concrete. That our work has to be carried out.
Yes. Okay. Thank you, sir. Thank you very much.
Thank you. Thank you. Is there any other questions?
Sir, I have one question.
Yeah.
Sir, you have added different percentage of fibers and along with the hybrid fiber also for the experiments. So the percentage addition of the fiber has any effect on the workability of the concrete?
Yeah, naturally, if you increase the volume fraction of fibers more than 1%, that will definitely affect the workability.
Okay,
And
so
concrete, and not only that will make the concrete harsh, and it is to be limited to you have to conduct a study with a different percentage of fibers and find out which is the one which is optimum. You have to find out.
so the superplasticizer is added to get that required workability. So
added to improve the workability.
So as the increase in the percentage of fiber increases, you increase the superplasticizer content also?
Yeah, in our case, beyond 1%, 1% to 1.25%, we have to increase the superplasticizer from 1.2 to 1.5, something like that. But it's not right. Simply, if we keep on adding superplasticizer, that will not work as you increase the fiber content. Fiber content should be limited to maximum possible 1%.
So, sir, this naphthalene-based superplasticizer, does it have any effect on the mechanical properties of the fiber? Sorry, the GPC? Because without superplasticizer and with superplasticizer, we get the same mechanical properties, or there is a variation between them?
Yeah, naturally. See, superplasticizer are required only to improve the workability. And the long-term effect of superplasticizer and on the hardened properties, that indicate that is not very much varying, only to fresh properties to improve.
Okay, sir. Thank you.
Okay. So if there are no other questions, I thank you for your kind attention.
Sir, good morning, sir.
Yeah.
Sir, I have one doubt. That is, can this type of concrete used in 3D printed construction?
Why not? Can be done. Already people started using ordinary concrete. Fiber concrete is only something like adding cement, sand, coarse aggregate. We add some metal, that is a short steel fibers. Okay.
Then coarse aggregate, what about coarse aggregate in that 3D printed while using it?
Yeah, this is all a developing field, and coarse aggregate with that is called a smaller scale coarse aggregate. People are adding with the 10 mm size, and we can increase to larger scale size. And that is as the technology is developing, we have to add these kind of things. It's all required with the small size. For example, ferrocement, we have no coarse aggregates, only fine aggregates. Ferrocement thickness is small, very small. Similarly, like that, people have to develop.
Yes, sir. Thank you.
Okay. So, thank you very much for your kind attention once again.
Thank you so much, sir. That was a very detailed presentation regarding this concrete technology and its sustainability issues and all. Thank you so much for this wonderful session, sir. Thank you. And thank you, sir. I thank all the attendees too for participating in it. And one more thing, that is for the validatory function, you can join through this link itself.
Okay, I'll try to join. Huh?
So please join if possible. I know you are busy, but we would very much like you to join, sir. Thank you.
Okay, thank you very much, Professor Laligati, and thank you for inviting me to deliver this keynote paper. Thank you very much.
Thank you, sir. Thank you all. The technical sessions have been commenced, and you can join. It has commenced 3 different venues. You can join through that if corresponding links to the technical sessions. Thank you. Thank you all.
Hello. ବୁଲି ପଳେଇବା ଆଉ କୁଆଡେ ଟିକେ ଭଲ କେତେଟା ହେଲା 95
Good morning, Professor Ravi Kapoor.
Good morning. Good morning.
How are you?
Good morning.
1 minute, please. I'm by phone today. I hope you're also good.
Yeah, we are good. Thank you.
Yeah. As you know, nice to meet you here.
Yeah, nice to meet you too.
As you know, today our rector planned to say some words about conference, about our cooperation, and I hope it's a good idea. And he has other event also in 11 o'clock by our time, 11. If it's possible to give him vote as it possible early.
Yes, we did it. Don't
Okay.
worry. No
Thank you
worry.
very much. We'll be waiting. After 7 minutes will be start, as I understand.
Yes.
Okay,
Thank
thank you. Thank you.
Good afternoon, Preeti ma'am. Welcome to the session.
Good afternoon, madam. Madam Professor Anatoly Kovrov who is the rector of Odisha State Academy of Civil Engineering and Architecture. Yes, joined.
Professor, good afternoon.
Good afternoon, sir. Welcome to this function.
Madam Professor Oleg Popov also has joined from
Good
Odisha.
afternoon, sir.
I'm here. I'm here. Настя, а ты подключилась? Все, давай. Потому что я тебя не видел, что ты подключилась.
Madam Professor Anastasia Pandas also has joined from Odisha.
Yes, she is also here, yeah. Professor Anastasia Pandas will be translator of our rector, okay?
Okay, sir.
Thank you.
Thank you. Shall we start?
Yes. Before beginning the event, I request each and every participant to kindly mute their audio for better clarity. I request each and every participant to kindly mute their audio for better clarity. Goodbyes make you think. They make you realize what you've done, what you've lost, and what you've taken for granted. Good afternoon to all the honorable guests gathered here for the valedictory function of ICI Test 2021. Firstly, let's thank the Almighty God for giving us this wonderful opportunity, this wonderful afternoon for the same event. For that, I invite Miss Meenakshi for the invocation.
നന്മയാകുന്ന കാന്തി കാണുവാൻ കണ്ണിനാകേണമേ നല്ല വാക്കിന്റെ ശീലു ചൊല്ലുവാൻ നാവിനാകേണമേ മൂകമാകുന്ന ഗീതമോ എന്റെ കാതിനിണയാകണേ സത്യമെന്നുള്ള ശീലമോടിന ശാന്തി അറിയണമേ ഭൂമിയമ്മയെന്നറിയുവാനുള്ള ബോധമുണ്ടാകണേ ജീവജാലങ്ങളാകെയും ജന്മബന്ധുവായിടണേ ജാതിഭേദങ്ങളിന്ന ശാപമോ ദൂരെ മറയണമേ ലോകമൊന്നിന്ന പാഠമെന്നുമിൻ മനസ്സിലെഴുതീണമേ Thank you.
Now, let's move forward with the programs of the day. For the welcome address, I invite Assistant Professor Thelma John, Department of Civil Engineering, Kochi Institute of Science and Technology. Ma'am, please.
Good afternoon to one and all. I feel very much privileged to deliver my duty of welcoming you all to the validatory function of the second International Conference on Innovative Trends in Civil Engineering for Sustainability, jointly organized by the Department of Civil Engineering TIST and Odisha State Academy of Civil Engineering and Architecture, Ukraine. At this onset, I take the privilege of welcoming Professor Anatoly Kovrov, Rector, Odisha State Academy of Civil Engineering and Architecture, Ukraine, to this august gathering. Professor Ole Popo and Professor Anastasia Spandas, Professors, Odisha State Academy of Civil Engineering and Architecture, has been among us in organizing this conference as we see it right now. On behalf of Department of Civil Engineering TIST, I welcome you, sir and ma'am. Professor Mangesh Kashyap, President, Serum, has been our motivator in organizing this conference. I welcome you, sir, to this gathering. Professor Dr. Preeti Teketh, Principal, Kochi Institute of Science and Technology, is a person who always shows a care and consideration to our department and motivates all of us. We welcome you, dear ma'am, to this event. Professor Ladhi Karti, Head and Backbone of Department of Civil Engineering, has been with us for the meticulous conduct of this conference. I extend a warm welcome to you, ma'am.
Thank you.
Next, I extend my wholehearted welcome to all the delegates, reviewers, chairs, and co-chairs to this gathering. Finally, my dear faculty members, non-teaching staffs, and my beloved students, a most delightful welcome to you all. Thank you.
Thank you so much, ma'am. Next, I would humbly request the guest of honor of the day for addressing the session, Mr. Anatoly Kovrov, Rector, Odisha State Academy of Civil Engineering and Architecture, and is an academician of the Academy of Construction of Ukraine, Chairman of Odisha Branch of Academy of Construction of Ukraine, Vice President of the Academy of Energy of Ukraine. Sir, I humbly request you for the session.
Я так понимаю, что я подключен?
Да.
Добрый день, дорогие друзья.
Good afternoon, dear friends.
Мы очень рады приветствовать вас сегодня на совместном заседании.
We are very happy to see you in the joint events.
Мы крайне удовлетворены развитием наших доброжелательных отношений с вузом вашим.
We're very happy for our relations with your university and your department.
И эта конференция, в которой мы с вами являемся соучредителями, действительно хороший шаг к совместным нашим мероприятиям, нашим действиям.
And this conference is extremely huge and perfect step for the future cooperation and development of our relation in the future.
В прошлом году, в декабре месяце, мы отпраздновали 90-летие нашей академии.
In the last year, in the December, we had a celebration anniversary of our academy, 19 years.
Это большая история, непростая история, которая насыщена большим количеством событий. Огромное количество всемирно известных ученых, которые работают в нашей академии, подняли имя нашей академии в Европе и в мире. И мы сегодня готовы к научному сотрудничеству с вами.
It's a very long walk and a very long road with a lot of different events, and we have a lot of famous scientists in the Europe, in the world, and now we very want to establish collaboration with you, and we hope for the future joint project and maybe students and teacher exchanges and scientific events for the future.
Успехи нашей Академии отмечены в декабре месяце большим количеством наград, в том числе президента нашей страны, кабинета министров нашей страны. И я думаю, что это действительно заслуженные награды, которые получили наши сотрудники.
In the last year, in the December, we got a lot of awards from President of Ukraine and Cabinet of Minister, and we very. It's a huge honor for us, and we share with you our happy.
Прошлый год был непростым для всего мира и для Украины в том числе, но тем не менее наша Академия, я знаю, что Олег Александрович говорил об этом, очень эффективно работала и продолжаем работать. Мы в прошлом году провели 16 научно-технических конференций, в этом году запланировано 15 научно-технических конференций.
In the last year was extremely difficult for all of us, for our academy and all over the world, but it was a very productive time for us, and in the last year, we spent 16 different scientists events, and in this year we will plan more than 15 conferences, and we all invite you for cooperation and to take part of these events too.
Мы удовлетворены тем, что проходили большим количеством участников из многих учебных заведений из разных стран, и призываем вас к участию в конференции, которая будет в следующем году. Last year.
We very satisfied for a lot of different participation of different point of the world in our conference, and we invite you to.
В том числе, Олег Попов, я прошу вас рассмотреть возможность соорганизации ряда конференций участников вашего учебного заведения, нашей конференции, соучастие в организации.
And we will very happy if your university to take part, and will also organizers of our future events, scientific events.
Естественно, мы вас приглашаем к нам в город Одессу.
Of course, we invite you in Odessa. It's extremely beautiful city. We very love Odessa.
Я думаю, что даже в это непростое время, и этот год тоже будет непростым, мы это все прекрасно понимаем, мы можем думать и надеяться на хорошие возможности.
Of course, now extremely hard time, but we hope for the future and invite you for Odessa.
Несмотря на те проблемы и сложности, которые существуют сегодня, я думаю, что мы обязаны быть эффективными и работать в этих непростых условиях еще более прогрессивно.
In this time, we of course are being obligated and work productive and successful and in this convenient now, of course.
Прошлый год был действительно очень эффективным с точки зрения вклада сотрудников нашей академии, научных сотрудников нашей академии в развитие нашего города, в развитие нашей страны. И мы уверены, что эта работа продолжается и продолжится в этом году.
We have done a lot of development for our city, for our Ukraine, for our country, and we hope that this development will bigger, and our teachers and our specialists will work more hardly.
Мы первые в Украине возобновили защиты диссертации PhD в прошлом году.
We first in Ukraine in the last year renewed to presentation PhD works in Ukraine.
Естественно, это было в онлайн-режиме.
Of course, it was in online.
И сегодня, завтра и послезавтра у нас защищается 6 PhD докторов.
And today, tomorrow, and in the future of a week in our academy will presentation more than 6 PhD work in the academy.
Да, скажи. Да, все. Okay. Это результаты не только этих 6 молодых людей, это результаты целого научного сообщества, которое работает совместно с ними.
It only results of these 6 students. It's the postgraduate students, I'm sorry. It's a result of collective of professors, our colleagues. It's very hard work.
И мы гордимся этим.
We honor of this.
Еще раз я хочу пожелать вам всем крепкого здоровья.
Of course, I wish all of us healthy.
Успехов в научной работе.
Successful in scientific work.
В творчестве.
In the creative.
Мира, благополучия.
Peaceful and prosperity.
И еще раз ждем в Одессе.
And welcome to Odessa.
До свидания.
Goodbye. Thank you.
Thank you, sir. Well, thank you, our principal, Professor.
Thank you very much, sir, for joining us for this valedictory function. And we are extremely happy that we have collaborated with Odisha State Academy of Civil Engineering and Architecture. We look forward for student exchange programs, faculty exchange programs, in the research collaborations, combined research publications, etc. And we would we would like to accept your invitation, and we will visit your academy once. And once the COVID problem is over, we invite you also to visit Kerala and visit this. And this is one of the first international collaboration that an engineering department is having with engineering department is having. We are already associated with that is collaborated with the University of Kelaniya, Sri Lanka, but that is for our MBA department. And we are extremely happy that Civil Engineering Department of TIST that has brought us this wonderful opportunity to collaborate with the Odisha State Academy of Civil Engineering and Architecture. And we would like to have you take your help in developing our own School of Architecture over here. That is our dream. And thank you very much, sir, for joining us. Thank you.
Thank you, madam. Thank you, Professor Anatoly, for joining and giving us that words of inspiration. And definitely our civil department is thankful to you. As madam said, we will invite you after this corona period is over. Thank you very much, sir, for joining. Thank you.
Thank you very much.
I welcome Professor Joseph, sir, to this valedictory function, who is joining us from Noida. Madam, Professor Joseph, sir.
Good afternoon, sir. Good afternoon, sir.
Good afternoon. It's my pleasure to be part of this valedictory function, and also the long relation built with Professor Nadiraj since we've been in Muscat. So I'm happy to be here in this conference. Thank you, Lati.
Thank you so much, sir. Thank you, Sir Anatoly Kovro. Thank you for the inspiring words and for giving us the details regarding the conferences and all the activities conducted over there, and also inviting us there. We would like to accept that, and surely we will have a meeting after the pandemic situation. Thank you, sir. Thank you so much. Now, for giving just an outline about the conference, I invite Professor Leti Karthi, Head of the Department and Organizing Chair of International Conference on Innovative Trends in Engineering for Sustainability 2021, Department of Civil Engineering, Kochi Institute of Science and Technology. Ma'am, please.
Thank you, Archana. And once more, a hearty welcome to the valedictory function of ICITES 2021. And definitely, we are all happy that we could successfully, complete this international conference on innovative trends in engineering for sustainability. So, the summary of the 3 days which we've conducted, the first day, inaugural session, and 1 keynote address and 12 presentations in 3 sessions. And in day 2, we had the keynote address and 34 presentations in 7 sessions. And today, day 3, we had a keynote address and 13 presentations in 3 sessions. And we are having the last valedictory function now. The themes, as I explained in the beginning, they're chosen based on the United Nations Sustainable Development Goals, which is related to various aspects of life on Earth. So we had 4 papers in good health and well-being, 8 papers in clean water and sanitation, 10 papers on affordable and clean energy, 36 papers in industry innovation and infrastructure. In fact, the theme of our international conference was sustainable infrastructure development. 13 papers on sustainable cities and communities, 3 papers on climate action, 5 papers on life below water, and 5 papers on life on land. So in total, we received 84 research papers, 14 international and 70 national. And we have the reviewers, the international from Oman and USA. And we have the national reviewers from Calicut, which is in Kerala, New Delhi, and Telangana, and also many of them from Kerala also. So these are the technical sessions we have conducted in 3 days. And I have just put a very brief on each session. I will just glance through that. In the first session, day 1, we had 3 sessions on 3 venues, and affordable and clean energy is the theme of one of the session, wherein we had 4 papers, and in which we discussed on methods of conserving energy by tapping the natural resources and need of the hour to emphasize on green building concepts. These are some of the photographs of the sessions we have conducted. Similarly, we had 13 sessions, so I'll just glance through this for the 13 sessions. So I don't want to take much time on this. We have actually done a detailed report on each session, which I'll be sharing with all the participants and the chairs, the co-chairs, the reviewers. So this is day 3, session 1, today's session. We had 3 sessions. The second session is Life on Land. And the third session, we had 2 presentations from Odisha. So in total, we had 84 papers, but some of them could not join us due to the connectivity or other problems, and we got 59 presentations. And definitely, all these things, it wouldn't have happened without the help of many. So definitely words cannot quantify how much support, guidance, and tips I have received from my mentors, friends, colleagues, associates, and well-wishers as this program we started in the beginning. Still, let me pause to place on record my gratitude to our chief guest of the inaugural session, Professor Ramu Damodaran, Chief UN Academic Impact, for giving us the inspiring inaugural talk, which really gave us a lot of motivation. The proactive management guest who always encouraged us for all academic activities. The ever supportive leader of our institute, Professor Preeti Tekut, the principal, the HODs of all departments, the deans, teaching and non-teaching staff for their cooperation as always. The rector, Professor Anatoly Kovrov, Professor Anastasia Pandas, and Professor Oleg Popov of Odisha Academy. Their association and participation are huge and also well appreciated by our management and the institute. Mr. Patricio, the editor of the UGC approved journal Sustainability Agri, Food and Environmental Research. Professor Mangesh from Pune of Siram will be joining us shortly. Professor Ashmita Dibekar of BNCA in my SDG Academy. Professor Oleg Popov, Professor Joseph V. Kanikal, and Professor N. Ganeshan, who delivered the keynote address on all the 3 days, giving a lot of insight into various aspects of sustainable infrastructure development. Ultratech Cement Limited for sponsoring our program, some of the programs, ICI, IGBC, ISTE, and Institution of Engineers. The reviewers, the authors of research papers, the participants, the chairs and co-chairs for their support. My friend and BTech classmate, the engineering chief, Anita Pardia for this PWD for extending his helping hand. And my cohesive team, the staff and students of the civil engineering department, for your support for making this conference a grand success. A big thank you to all of you. I'm sure all the participants might have received some novel, relevant, sustainable ideas and thoughts for research work or for implementation or for product development, which can be shared with your friends, students, or colleagues for the betterment of life on Earth. Thank you. Thank you, Ananda.
Thank you so much, ma'am, for briefing it so beautifully, like no one else. Now, we have a special address by Dr. Mangesh Kashyap, President, CERA.
I think he has not joined. He's here.
Sir, please.
Sir, you're on mute.
Yes. Am I audible?
Yes, sir.
But my time has not started yet, no? That's why I would like to listen some other views also.
Okay, sir. I'll ask our principal to then.
Yes, me too. Yeah. Sandeep.
So next we have the address by Professor Dr. Preeti Theke, Principal, Kochi Institute of Science and Technology. Ma'am.
Good afternoon, all of you. Respected Professor Anachali Pauro, Rector, Odisha State Academy of Civil Engineering and Architecture, Professor Oleg Popov, Professor Anastasia Pantas, Special Guest Dr. Mangesh Kashyap from Seram, Professor Joseph, HOD Professor Levi Karti, other distinguished guests, faculty members, participants, and my dear students. Actually, when Professor Levy told me that they are going to have the international conference online, I was wondering how this will happen. 84 conference papers they have received, and how we will conduct it online. But I am really impressed with the department that you have conducted it very well, and I am extremely happy that we could organize such a 3-day international conference in association with Odisha State Academy of Civil Engineering and Architecture, and a special thanks to Professor Kouro, Professor Oleg Popov, and Professor Anastasia Pantas for giving us this opportunity. And this is the first international conference of this sort that is being done in Kochi. The first, and Civil Engineering Department is the first department to bring an international MOU into Kochi. And even though that is, we have our MBA department, first engineering department to bring in an international MOU is the Civil Engineering Department. I am proud about the department. And regarding the conference, and that is what I would like to say is, sustainable infrastructure development has a special focus on energy, water, land management, smart technologies, use of sustainable and durable materials, etc. I am sure that the conference served as a wonderful platform to establish national and international research collaborations in the field of sustainable development. I hope the department will pay a special focus to the last objective of this conference, that is to develop new novel proposals in adopting various sustainable infrastructure development. So this will attract more research funding into the department, and that is, we were, as Professor Kouro correctly told, we look forward for more student exchange programs, faculty exchange programs. We will surely participate in all the international conferences organized by Odisha State Academy of Civil Engineering and Architecture, and I would like to express my special thanks to Professor Ramu Damodaran sir also in this, and Professor Asmita Joshi, who helped us a lot in organizing this international conference. So, I once again I congratulate both Odisha State of Civil Engineering and Architecture as well as Civil Engineering Department of CIST for organizing such a wonderful international conference. Thank you. Thank you.
Thank you so much, ma'am, for briefing that. Next, we have the special address by Dr. Mangesh Kashyap, President of Seram. Please.
Am I audible?
Yes, sir, you're audible.
Okay. Just a minute. It was a really wonderful last 3 days that we had various interaction with the various people, expertise, and what we can say, great contributor to make this planet beautiful, livable, and what we can say, sustainable. And the major theme of the conference was sustainable infrastructure. And without sustainable infrastructure, our next generation cannot survive. And so entire these 3 days were very good amalgamation of thought process, churning of new ideas, and what is doable, what is not doable, and experiential learning which is involved in all this entire. My personal portfolio is about the water, sanitation, and economics, because being working in the field of water governance and economics, I always emphasize on economics of any particular. And as far as 2030 agenda concerned, that agenda is more focusing on poverty removal, quality education, climate change, and water, clean water, and sanitation. So actually, even though you have already wrapped up the conference proceedings and all these things, I think that I should little bit contribute about what is water, what we can say. Just a moment. My screen is, are you able to see the screen?
No, sir. No, sir. You have to present it.
Okay. Is it right now?
No, sir. It is not visible.
Are it? If there is any other option, just a moment. Okay. It's okay. It's meeting. Sorry, unfortunately, I cannot. Just a moment. Okay. ठीक है. Anyhow, see, as far as water, sustainable water development, governance, sanitation, these are the 3 things which is very important for the development of GDP. Our entire GDP is depending upon the water governance system, water demand and supply. At the same time, sanitation is also there. While thinking about the next 10 years, Agenda 2030, we are facing a very huge challenge because of climate change effects on water resources. As far as India concerned, we are having very different kind of land structures in various different states. We are, as far as Maharashtra concerned, we are having more than 30-40% basalts there, which doesn't have any water holding capacity. And we have to think about how we can increase our water holding capacity to supply water in drought prone areas, or whether there is water is not available in villages, we should be able to supply drinkable potable water to those communities. And for that, we have to be with the sustainable technology. Now when we think about the technology, modern technology and the indigenous technology, we have to take good things from both of these technology, and we have to create one fusion of this technology. As far as when we think about the state like Kerala, what we call is a Devbhumi, and a very beautiful nature, and all these things are there. But there are also some kind of water scarcity problems like Maharashtra. So what is the solution? So sustainable development goals emphasis on the solutions, and solutions, implementable solutions. So we have to think how we can implement. As far as UN agenda, when we think about the UN agenda, they have provided us solutions for each and activity chart. SDG agenda, they have mentioned 170 targets, and 170 targets which are scattered into 17 goals. And when we think about each target, and when we relate that target with our current demographic situation, we will be able to find out some solution on local level. So from global to local and local to global, this is one again journey which we must have to follow the entire protocol of this SDGs solutions. One another thing, what I observed that in our conference also, I heard some speeches, especially that Popo and Ramu Damodaran. What I think that all the solutions we are thinking about implementation view with immediate effect. There are some solutions which are not possible to implement right now because the situation and the current atmosphere doesn't allow us to go with that technology. So technology is what, according to my opinion, technology must be related to our indigenous knowledge, indigenous practices. For example, when we think about in our Maharashtra, we call this the word Paras. And Paras is the place where we plant coconut and bananas and chikus, so that the water holding capacity of these plants is good. Not only that, they purify our wasted water, and that waste water get purified, and that the water is percolated to further places. So automatically groundwater level gets upgraded, and we get a good quality groundwater return from that. Now, when we think about the next generation, we are using water as a commodity. When you think water as a commodity, it will not survive, it will not serve our purpose, because industry need a huge water. For domestic purpose, we need a huge water, or any other purpose we need a water. But when we think water is a very essential and important product, and we have to be controlled our water use. So when we think about the water use pattern to be changed nowadays. Recycling is very important in case of water, because I am damn sure that in 2025, all we need to purchase 1 liter of water for 500 rupees. Are we ready to pay 500 rupees for 1 liter of bottle of water? If not, then we have to think seriously how to spend each drop of water, and each drop of water is having some cost. There is a purification cost, technology cost, a lot of costs are involved in the water, and that cost will definitely going to affect on our day-to-day life. So when we think about the development, think about the usages of water. We have to change, we have to make a basic mindset change in water users association. That may be domestic water users, industrial water users, institutional water users, and then and only then we can save a lot of water, which will serve the purpose of sustainable development. And that is why economy of water or economy of the environmental resources is very important. While working on one committee of state government of Maharashtra, I am involved in water management services, water supply, water demand and supply committee is also there. And basically now we are emphasizing on the climate change, which is very important part, and that is affecting on our water resources, water availability. So how we are going to cope up with the climate change situation? And climate situation is a personal concern for all of us, because if we reduced to emit minimum carbon, or if we used to use recycle all these things, if we decided to not to go with the huge carbon stored, so there is very important role for all of us on individual level, on personal level. Kindly reduce your footprint, carbon footprint. That is also one again important part. Then we have to reduce our food footprint also. If our conference we could have conducted in physical manner, we must have organized one buffet and food counters and all that. You just think how much food would we have been wasted during that time. Okay, so food footprint we must reduce. We must reduce water footprint. We must reduce carbon footprint. All these things are affecting on climate change. So if we keep a habit of using minimum natural resources, or if we can use maximum use of whatever we are holding today, that might be a reusable plastic, that might be a reusable electronic gadgets, that might be a reusable cotton. So why not? And so the government of India, United Nations, all these organizations wants that we should go with this recycled technology. We should focus on 4 R's: repair, reuse, refurbish, and recycle. So these 4 R's, they are going to support our circular economy. Circular economy means that is a one win-win situation. We must have to use our holdings, whatever we are having, so that we can save our money. We can use that money for our further development and quality life improvement. So whenever we think about the circular economy, we must have to think reverse engineering about the reuse of water and all other things. So my intention is to have a dialogue with you all people is about the think about the circular economy, wherever it is possible to implement recycle theme, please implement in your institution. As far as our institution is concerned, that is Banabai Nanavati College of Architecture, we are using maximum recycled material. We are having labs, we are using our recycled material in labs. As far as architecture college is concerned, we are having some furnitures, but we are using that furniture again and again in different kind of designs. Even though we are using metal also in recycled form, recently we have manufactured one seating arrangement of wasted iron plates. That wasted iron plates we have we got from some other client that they were reconstructing their lift, and we get some material, that raw material of that lift, wasted material of that lift, and out of that lift we have made some sitting arrangement for in our canteen. A lot of things we are recycling and we are remaking, we are repairing, and we are using that, so that we have last year we have saved more than 60 lakhs rupees of our entire allotted budget for furniture, and that 60 lakhs rupees we are now using for implementation of rural women empowerment, capacity building, and all these things. So circular economy is working like this way, and that is the one way to get enriched through knowledge, through technology, through natural resources, and of course it's once again one kind of seva to divine energy also, what we can say, seva paramo dharma. So it is a services to nature, services to environment. So I think that we should come together in future also. Whenever I got some time, I spoke to Karthi madam also about how we can work together, how we can join together for one workshop or any symposium or any kind of field activity, so that we can percolate this circular economy thought, we can percolate the proper and potential use of water. We can show demonstration about how these climate change technology are going to affect on our day-to-day life, and how we can keep away all these bad effects of all these climate change issues. So I think that this is because my time is over, as far as the time whatever given to me, my time is over. And thank you very much, Karthi madam, principal madam. You people have done a lot of work, lot of hard work to get success of this conference. And I pray in future also we'll come together and we'll have some good interaction with students, faculties, and parents also. Because see, parent is very important factor according to me, because we have to conduct one workshop for parent also, because how to behave with the nature, and parents are the basic element who decide how to behave with the natural resources. That Popo sir is laughing this thought, but parent is very important, and we have to involve all parents from childhood to graduation. PG students, parents must involve in all these activities, because they are our asset. They are having a huge of waste material in their home, and they are trying. See, generally Indian mentality is that if I sold out that waste, I will get some money. But that money for temporary. But if you return that and if you make something new out of whatever you are holding, that will cost a lot, and that will save our nature. That will be the asset for our community, our society. So the public participation, institutional role, and experts role, and the actual field work. These four things must be together so that circular economy will get boost. And I am damn sure that in our GDP, the natural resources income must be raised by March 2022 financial year. हमारे GDP जो है वो GDP should get rise more than that 2 or 3% just because of the circular economy. Thank you very much. Thank you, Principal Ma'am. Thank you, Karthi Ma'am. And thank you all your team members. Those are lovely team members. And I say hands up to them. And thank you very much. Thank you.
Thank you, sir. We are really inspired by your talk. And surely we would like to associate with you. I am sure that the team is surely that is come forward, and that is we also would like to know more about this, because this circular economy which you are discussing is really nice. So we look forward for close association. Thank you.
Ma'am, in fact, thank you, Dr. Mankesh. Dr. Mankesh was saying that they will associate with their university also, and we are looking forward to the World Water Day celebration in March. So we
will do it along with them.
Yes, madam.
Yeah, thank you, madam.
Yeah.
Thank you, sir, for joining. I want Professor Joseph, sir, also to say a few words, sir.
Hey, good evening. I'll just take 2 minutes, not more than that. See, I look forward that, as I mentioned in my keynote, there is infrastructure development going to be in a big way, and this is going to be in a different shape after post-COVID 2019. So this is what we need to understand, and we need to give a lot of importance on the environment, and that is the prime importance globally, looking at reducing the carbon emission and the CFC gases on which we are planning the infrastructure development. Largely, the sector in India is going to see a large business opportunity on the investment from the West to India, because the energy sector is going to have a different technology to address the global issue of the CFC gas emission. And I look forward, wherever I am, to have a good collaboration with your institution. And we are on specialized MBA offering, and we will see how we can collaborate in future. And of course, Dr. Lati is there at the institution, and also I look forward to in the near future to meet you and your principal and the other professors at the institution, and let's do the best in future. Thank you for inviting me to this conference, and it was a wonderful event, and the sessions which I attended, it was good things. And at this pandemic situation, you could organize with the time difference between the countries and then get people on board was an excellent, way that you conducted. And thank you once again. And I wish you in future all the best. Thank you.
Thank you very much, sir. Thank you.
Thank you, sir. Thank you, sir. We would like to collaborate with you also. Thank you, sir.
Sir is working actually a part of Amity University, not
Yeah,
exactly.
yeah,
Amity. Sir, what's your, can you just, Joseph, sir?
Yeah.
So actually part of Amity University only, I think their extension
yeah, so this is a UK-led business school, but we are part of, we are affiliated to Amity University. So the degree is awarded by Amity, but we have an academic independency on our curriculum design, and we are the only institution in the country who is offering MBA programs related to civil engineering subjects. That is on construction.
We have MBA department over here, sir. We are one international collaboration we have with the University of Kelania.
Okay. Yeah, I heard you saying that with the Sri Lankan University. Yeah. But ours is a typical MBA program towards the construction project management and the real estate and quantity survey. We are the only one, our construction project management also accredited by Project Management Institute.
Oh.
So you don't have any other institution in India who got this accreditation. So it's a specialized MBA, what we call it as. It's a 2-year program similarly, and degrees awarded by Amity and within the regulations of AICT.
Thank you, sir.
Thank you, sir, for joining us.
Yeah, thank you.
Professor Oleg Popov, I want you to say a few words.
Thank you, Professor Lati. Thank you. Yes, why not? For the first, let me to say thank you again. Thank you for the organizing, for the very professional organized of this conference. I think it's a work of Department of Civil Engineering. Special thanks for the very professionalism of Professor Lati. She was fantastic, and very sorry that we are sometimes not first answer. So this time it's a holiday time in Ukraine usually. Only today we start the work in usual time. I very hope and I'm sure that next conference, next our joint conference, will be with much more participants from our side and maybe not from our university, from our other university. So your topics is very important in our life. In real, even in this situation of pandemic, our building don't stop, and we must to work. We must to make a scientific works, must understand what happened with our buildings and other etc. So thank you very much. I hope it's not last our event, our conference, both of India, on Ukraine, in Kerala and in Odessa. Thank you very much again. And
thank you.
Thank you, sir. And this is the first international conference. We will continue this almost every year, once in Israel and the next time in Kerala. Then we will have.
Thank you too. Thank you.
Thank you, Professor. Actually, my classmate, Engineer Anil Tripathi is there. He is in Orissa. I don't know whether he'll be able to talk because I think he's traveling. Would you like to say a few words? I think not possible. He has helped me a lot with sponsorship and all to conduct this conference.
Thank you, sir.
Okay. I would like to, call upon Professor Anastasia She was supposed to say a few words before, but then she said later.
Of course. Greetings from Odessa again. I am extremely happy for opportunity for me, for my colleagues, for Academy generally to take part in this event. It's a huge honor for us. Our collaboration has begun recently, but now we have results during conference at a high level, I think. Thank you very much for organizers for our work, extremely hard work. Thank you, and thank you all participants for activity at a difficult time for all of us. And I hope that on the start of our productive and successful collaboration, we look forward for joint project, scientific events, and welcome to Odessa. And I wish all of you a healthy, happiness, prosperity, and thank you.
Thank you, Professor, and wish you also the same. Let's hope that we will meet in person either in Odisha or in Kerala.
Hello, Lati.
Yeah, yes.
I think I'm audible and
yeah, you're audible.
To speak.
Yes. Please.
Thank you for inviting me to the August gathering. I regret for not being able to attend because of my busy schedule. I hope my son Assis from US must be hearing this one. And I thank all the participants from Odisha. I wish you all the best. And I think such type of meetings we will conduct very frequently. And from the next time onwards, I will try to be attentive. As in the class, I was able to attend all the classes with you in my engineering camp. Thank you. All the best.
Thank you. And
Thank you, sir.
He's my classmate in REC. And his son reviewed some papers from US. He's in US. So thank you, Anil, for joining, and his colleagues have joined for attending the different sessions. They were there for all the sessions. Thank you again. Okay, over to you, Roshna.
Thank you so much, ma'am.
I just wanted to contribute one thing, that SDG goal number 17, which talks about the partnerships, and Talkage Institutes and Lucky Madam, they are already successful in getting partnerships, various partnerships, because of this common platform conference. And SDG started working like this because of partnerships. A lot of resources will get available, a lot of expertise will get available, and of course the entire what we can say growth of the nation is going to be there. Because and next conference I think that we will organize in physical way, because vaccination is going to start from 16th of Jan, and all we will be getting vaccines, and we will have a very healthy life in future. So we'll come together, we'll share our thoughts, and we'll work together, come together, work together, eat together, and grow together is the mantra of economy. So we have to be very much enthusiastic about the next conference. We will be waiting for that. And as Joseph sir also pointed out, there are very much huge opportunities in various sectors. Investment sectors, that investments in sanitation, investments in climate change, a lot of investments portfolios are coming up. At next conference, we should focus on one another area also, opportunities for investment. Thank you very much.
Thank you very much, sir, for sharing that motivation with us. I once again thank all the honorable guests for giving the address speech, and I once again thank our principal Dr. Mangesh Kashyap sir, Joseph V. Thanikal sir, Anastasia Pandas ma'am, Oleg Popov sir, everyone for giving that special addresses. Now we have a small feedback session. If anyone from the participants of the international conference wants to share any kind of their experience of these 3 days, they are most welcome and the platform is yours. If anyone wants to talk about the international conference, are welcome. I guess we don't have any comments. So let's move forward to the time for which we were all waiting for. That is the declaration of the best paper under each theme. For that, I invite Professor Ladhi Karti, HOD and Organizing Chair, ICITS 2021, Department of Civil Engineering, Tockage. Ma'am, please.
Thank you, Roshna. I am really honored to declare the papers which have won the best paper award for each session. Actually, we had 13 sessions, and since the chairs were different, so we thought we will give the best paper based on the sessions, not the themes, because the marking will be different. So I don't want anybody to feel bad because it was chaired by some other chair. So we have decided to give the best paper for each session. So day one, Venu one, the theme was affordable and clean energy. The best paper goes to thermal efficiency analysis of buildings with phase change materials, presented by Shabana M. Taha, Bennett Kuriakos and Rajesh Bedi. So we'll be giving the best paper award for this particular paper. Day one, Venu 2, the theme was good health and well-being. And the best paper award was to review on sponge city construction for flood management by Femina Maria. A1 Venu 3, the theme was clean water and sanitation, and the best paper award goes to sustainable water treatment technologies, which is again a review paper by Dr. Asha Piton and Dr. Venu Pavels. Day 2 and 3 combined because the themes were for both the days were industry, innovation and infrastructure. For session 1, Venu 1, the award, best paper award goes to prediction of joint shear strength of RC beam, column joints subjected to seismic loading using artificial neural network, presented by Shreyas Alagundi and Palmiswamy. And session 1, Venu 2, the best paper award goes to structural applicability of plastic incorporated concrete, presented by Alicia Anna Saju and Smita Keke. And for session 3, Venu 2, bond strength properties of confined and unconfined composite aggregate concrete by beam splice test, presented by Senthil P. Matthew, Sujata A. and Yashida Nadir. Session 3, Venu 3, the best paper award goes to a review on the influence of shrinkage reducing admixtures on concrete, presented by Angel Rose, Jerison Scaria James, Dr. Elson John, and Sachin Paul. Session 3, Venu 3, researching of properties of expanded clay concrete on cement ash binder, presented by Kristiakov A. and Popovo. It is we received from Odisha. Day 2, the theme was Sustainable Cities and Communities. Session 2, Venu 4, the best paper award goes to working posture analysis of construction workers using ergonomics, presented by Anaka R. and Annie Sonia Xavier. Session 2, Venue 5, Improvement of Sandy Clay with Lime and Nylon Fiber by Athira T. and Sunny T. Day 2, Session 2, Venue 3, the theme was Climate Action. The Best Paper Award goes to Review on Carbon Capture and Storage for Construction Engineering by Edulakshmi Nair. Day 3, Session 1, Venue 1, theme was Life Below Water. The Best Paper Award goes to Shoreline Change Analysis along the Udupi Dakshina Kannada coastal stretch in Karnataka, west coast of India, using ESAS, presented by Anchita N.A. and Tarak GS. Day 3, Session 2, Venue 2, the theme was Life on Land. The Best Paper Award goes to Suitability of Demolition Waste as a Landfill Liner Material, an Experimental Approach, presented by Devika B., Harish KV, Samuel Devi, and Mohammad Shias. So that is regarding the best papers on all the 13 sessions. We will be giving the Best Paper Award certificate to all these winners. Thank you. Over to you.
Congratulations to all the prize winners.
Congratulations to all prize winners.
Thank you so much, ma'am. And I once again congratulate all the participants for winning. With that, we come to an end to this validatory function, and for the vote of thanks, I invite Assistant Professor Anju Paul, Organizing Secretary, ICI Test 2021, Department of Civil Engineering, Kochi Institute of Science and Technology. Ma'am, please.
Good evening, one and all. Thankfulness is the beginning of gratitude, and gratitude is the beginning of thankfulness. With a deep sense of appreciation, I recall all the effort we, as a team, have put together these days was extremely fruitful. Since I am assigned to extend vote of thanks, let me start thanking each one of you wholeheartedly for your stewardship. I, Assistant Professor Anju Paul, on behalf of ICITES 2021 team from Department of Civil Engineering, Kochi Institute of Science and Technology, would like to extend my most sincere thanks to the Almighty God. I support extended by our eminent management team is remarkable in hosting such a conference in an institute. Dr. Alex Matthew, the President, Dr. K. Varghese, the Founder, Director and Manager, Mr. K. A. Simon, the Secretary, Mr. M. J. Johnson, the Treasurer, Professor Dr. P. J. Joseph, the Director, and all our beloved directors of Kochi Public School Society have extended their full support for the successful conduct and hosting this international conference of innovative trends in engineering for sustainability, ICITES 2021, here at TIST. On behalf of the entire Civil Engineering Department and the organizers of ICITES 21, we extend a wholehearted gratitude to you, sirs. I take great pleasure in extending our heartfelt gratitude to the chief guest of our inaugural ceremony, Professor Dr. Ramu Damodaran, Chief, United Nations Impact, who spared time from his busiest schedule, even during odd hours of the day, to be present during the inaugural ceremony of ICITES 2021 and enlighten us with a valuable message. Thank you, sir. We acknowledge the unwavering support received from Odisha State Academy of Civil Engineering and Architecture, Ukraine. Now, I sincerely express our gratitude to our guest of honor of this function, Professor Anatoly Kovrov, Organizing Chair, ICITES 2021, Professor Oleg Popov, Organizing Secretary, ICITES 2021, Professor Anastasia Pandas, and all other officials from Odisha State Academy of Civil Engineering and Architecture. Thank you all. We are thankful to Dr. Mangesh Kashyap, President SERA, for their continuous support and advice, and also for the publication of our papers in the Journal of Environment Observer. Thank you, sir. Also, I am taking this opportunity to share our sincere gratitude to Professor Ashmita Joshi Divakar, Director, UNIHub BNCA, for timely support as it has greatly helped towards the success organization of this venture. Thank you, ma'am. At this junction, let me thank Professor Patricio, the Chief Editor, Journal of Sustainability, Agri, Food and Environmental Research, for accepting our request publishing the papers in their UGC-approved journal. Thank you, sir. Next, I would like to express our deep appreciation and gratitude for the overwhelming response from the officials of Rebuild Kerala to this conference. I take great pride to acknowledge our keynote speakers, Professor Oli Popo, Odisha State Academy of Civil Engineering and Architecture, Ukraine, Dr. Joseph P. Thanikel, Associate Dean and Director, School of Construction, RICS School of Built Environment, Amity University, Noida, and Dr. M. Ganeshan, former Professor and Dean, Department of Civil Engineering, NIT Calicut. As we know, all these eminent personalities were kind enough to take time out of their busy schedule and showered us with their pearls of wisdom and knowledge. I am very much thankful to all the sponsors of this conference, especially Engineer Anil Kanta Tripathi, Engineer-in-Chief, Orissa PWD. Without their generous support, it would not have been possible to organize this conference with this elegance. Thank you, sir. We are highly appreciative of the leadership, encouragement, and extensive support provided by our dearest principal, Professor Dr. Preeti Tekut. Thank you, ma'am, for your constant support. I'm taking this opportunity to thank Professor Dr. Joseph E. Thanikel for his presence. Thank you, sir. I am boundlessly thankful to our advisory committee for the continuous support, prompt advice, and valuable suggestions, which have greatly helped towards the successful organization of ICITES 2021. Thank you all. I take this opportunity to thank all the reviewers, chairs, co-chairs, and technical committee members for providing their valuable comments in time, and it helped towards the improvement of quality of papers presented in the conference. The participation of the delegates shall undoubtedly mark the success of any conference. The authors have spent time in scribing their research work and present it before a forum. Hope they are the most beneficiaries of this conference. A wholehearted thanks to them from all of us. I would like to express my deep gratitude to deans and HODs from other departments for their presence and motivation throughout. Events like this cannot happen overnight. The wheels started rolling months before. It required planning and a bird's eye even for the minute details. We have been fortunate enough to be backed up by our vibrant HOD, Professor Lidhi Karthi, Organizing Chair, ICITES 2021, because of whom we have made this event possible. I am taking this opportunity to express our sincere gratitude to you, ma'am. Thank you, ma'am. A self-motivated and a dedicated crew from the Department of Civil Engineering, grouped as organizing secretaries with Dr. Vasudev R., Dr. Smita K.K., along with me, Anju Paul, an organizing committee with all the faculty members from Civil Engineering Department pitched. All of them knew their job and worked towards the common goal, which paved the way for this sweet success. I cannot thank everyone enough for the level of involvement and willingness to take on the completion of tasks beyond their comfort zones. Thank you all. The active involvement of our technical staff of the department and constant support of Mr. Ridesh, Mr. Manoj, and Mr. Joby of the Telepresence Lab, O4 Institute, deserves honor at this moment. Thank you. I'd like to pass a special thank you note for Ms. Roshna George and Mr. Rasid Raihas of S7 Civil, who worked with the organizing team, student coordinators of all the venues, and all the students who have participated overwhelmingly and for making the event more cheerful. Last and before I wind up, once again, I would like to propose my vote of thanks for all who have helped us directly or indirectly in making this conference a resounding success. Thank you.
Thank you so much, ma'am. Now, let's have a beautiful end to our ICITS 2021. With all due respect, let's recite the national anthems of both the nations.
No. Two. One. Thank you. Thank you all once again.
Once again, I thank all participants and attendees and all the delegates for attending ICI Test 2021. Goodbye and have a good day ahead.
Thank you all. Bye-bye.
Bye. Thank you. Thank you all.
Thank you. Bye.
Thank you. Bye. Congratulations, Legends and all faculty of civil engineering department, students, Roshna, and that is for making this event a grand success. Proud of you.
Thank you. Thank you, ma'am.
Thank you, ma'am.
Those words mean a lot to us. Thank you.